Welcome to Chapter 9. We'll look at tree files before getting onto the problems. This is because we're asked to make use of stack, queue and dequeue for all of them. Let's start with our custom stack. We use a list under the hood. Size returns, so it's shown here as part of the new function. Size returns the length of stack. Push adds an element to index 0. So insert 0, item. Pop removes the item in location at index 0. Peek returns none if the stack is empty. If not, we return the item located at index 0. Display just prints the stack to the screen. With this background, let's look at custom queue. Enqueue adds an element to the end of the list, since we use list as the backing store here. Dequeue pops the element from location 0, so it's first in, first out. Peek returns none if the queue is empty. If not, it returns the element at location 0. Display is just printing items to the screen. Size is again length of the queue. This is where a fun trick comes in. You can implement a dequeue with a stack and a queue. So we use function aliases to get things done. Since I'm going to use list as the backing store, you can use either stack new or queue.new. I'm using queue.new. Push back, we'll use enqueue. Push front, we'll use stack.push. Pop front will remove from the stack, but it's okay, you can use a queue as well. Display will call queue.display. Peek front will call stack.peek, and isEmpty is making use of queue.isEmpty. You can make use of stack.isEmpty as well. These two functionalities are not provided as part of stack and queue, so we're defining it here. Pop back will remove the last element, and peek back will return the last element if it exists. If not, it will return none. With this background in mind, let's look at rest of the questions. The third question in the first part asks us to evaluate a postfix expression. The good thing about this is we don't have to worry about operator precedence. Everything is already taken care of. So if we were to just take the small expression 5, 2 and the exponentiation operation, this is going to produce 5 square, that is 25. So here's how we get it done. You create a new stack, and for every token, so since we're using split, it's going to return a list of strings. For every token, the very first time we'll encounter 30. This is not in operations, so this is not in one of the arithmetic operators, so we push it as a float. 5 also we do the same thing, and for 2 as well. When we encounter the exponentiation operator, we pass this check, pop 2 elements, and this is the important part. Operations of token will give you a pointer to a function. So here it will give operator.pow. So each of these functions take 2 parameters, and the first parameter is on the left side, the second one is on the right side. So if we consider pow of a comma b, it's going to return a power b. Sub of a comma b is going to return a minus b. So we invoke this function using left and right. Operator is a built-in module in Python. Here we have a map, a dictionary that maps the string to the function, and we push the result back to the buffer. The top of the stack, once the entire expression is exhausted, will contain the result. So that's what we're returning. So here's the demo. The result is 3. Let's now turn our attention to the sixth question. We're asked to print the string in reverse order. The idea is straightforward. We keep pushing characters of S onto a stack and then keep popping, and we'll get our result. Here's a demo. When we try to print hello in reverse order, we get ole. You can try the rest yourself. Welcome to the seventh question. We're asked to use a stack to check if string is a palindrome. A palindrome is a string which is the same whether you reverse it or not. So if you consider LOL, it doesn't matter whether you start reading from left to right or right to left, it is the same. If you consider the string nope, it's not the same whether you read it forward or backwards. So that's what we're supposed to do. I've given an additional implementation using a queue. We'll get to it in a minute. As far as using a stack is concerned, first thing you do is push the characters of S onto the stack. So since stack is going to get you the reverse of a string, now as long as you're iterating the characters of the given string in forward direction, and when you pop from stack, it basically means that you're iterating through the stack, you're iterating through the string in reverse order. If they're not the same, then you return false. If not, you return true. That's about it as far as the stack based implementation is concerned. Now let's look at the queue based implementation. Create a queue until half of the string, enqueue it. Now go ahead and read elements from the queue and compare it against starting from the end of the string. If they're not the same, then return false. And if you reach the end of the queue, then you return true. Here's the demo for it. There we go. Welcome to chapter 9, the third question in part 2. For this, we're supposed to run a dummy restaurant business. So here I've reduced the range to 100 and 101. We'll uncomment this at the end of this demo and get rid of this statement. Here's what we're supposed to do. We start with a fixed number of tickets, and for every order a customer places, we assign a random ticket to them and add their order to the waiting queue. If we get more orders than the number of tickets, we reject the incoming order. Waiting queue prints the order status, that is the queue of items that are there in hold. The third option, order is ready, means that the customer can be served. So we take the first customer who came by and serve their order. If the order queue is empty, we inform that the order queue is empty. So let's look at this in action. Choice is 1. Order 101 got to queue. Remember the random choice for a ticket. Let's look at the queue. We have one order in queue. Let's add one more order. That also went through. Let's try adding one more order. Order queue is full because there are no more tickets. Let's view the queue. Serve the first waiting order. Alright. Now let's go ahead and add one more order. That got back to queue. Let's view the queue again and kick out one order. Let's go ahead and send the next order out as well. Now you see that there are no more orders in the queue. If you view the queue, the order queue is empty, and finally we quit. Let's now go through the program and understand. So here's a helper function display. If the queue is empty, then we print a message. If not, we display the orders in queue. You can definitely make it as pretty as you want here. Now this is the menu that's going to get displayed every time. We use strip because we don't want this new line and we don't want the last new line as well. Now we go ahead and use a while loop. So if the choice is 4, then we break out of the while loop. For any other choice that's a numeric input, we say it's an unknown choice. The first thing that we do when we want to add a new order is see if tickets is empty. If it is, then we inform the user that order cannot be placed because the order queue is full, and we continue. If not, we pop a random element. Remember that randint produces a random integer including both the start and end points, so that's why we have the -1 here, and we enqueue, displaying the orders we just saw now. As far as choice 3 is concerned, if the queue is empty, then we print a help message saying no orders in queue. If not, we dequeue and recycle the ticket. We move it back to the tickets, and then finally we inform the user that order is ready. That's how this whole program runs. Welcome to the fourth question, part 2, chapter 9. Here we are asked to display a stack in a sorted order using an output restricted dequeue. An output restricted dequeue is a structure where you're allowed to add elements both in front and back but you're allowed to pop elements only from the front. Here's the stack input to the program, and here's the output. After sorting the stack, this is the DQ. So let's see how this is done. So first up, to create the stack, we use a stack new and then keep pushing items onto the stack. We display the stack before sorting, which corresponds to this output, and then we call sort stack. You're familiar with these two modules, custom stack and custom DQ. So let's see how this works. To confirm that there is no call to pop back, when we do a grep, it returns nothing. Pop front is allowed, so we have that in place. Now let's get into the details. There is a bug in the textbook that says that as you pop elements from the stack, if the DQ is not empty, compare the first element of the DQ to the popped element. If you have to insert at the head, that is if the element is, the top is actually less than the first element, then you go ahead and add it to the DQ. So this way we're aligned with the textbook. If the DQ is empty, or if you need to add it to the front, add it. If you need to add the element to the end, the top element, add it. But here's where the textbook algorithm breaks. If you find an element that is between the smallest element in the DQ and the largest element in the DQ, then your partial sorted order is going to break. So let's see that in action. First you'll add 40 to the DQ, then you'll add 60 to the end, so it will be 40, 60. Now you'll encounter 30, so 30 will be added to the front. You'll encounter 20, 20 will be added to the front as well. 0, 0 will be added to the front. Now let's see what happens when you encounter 10. Here's what's going to happen when you encounter 10. Your DQ is going to look like this: 0, 20, 30, 40 and 60. This is in sorted order. But when you compare 10 against the head of the DQ, you'll see that it's greater, but it is actually less than the last element of the DQ. So this is what you need to do to account for that. So look at the front. 10 is greater than 0. So you push 0 back to the stack. The next time you compare, this condition will be satisfied. The current element will be 20, and 20 is actually greater than or equal to 10. So you'll end up pushing 10 here, and 0 will be in the stack. So in the next iteration, 0 will find its right place, which is right before 10. So that's how you get the output. Those of you who are concerned about calling this display method, I've added a helper function here, size, that uses q.size. You can use stack.size as well. So you go ahead and iterate through the DQ, and you pop front, end it by a space, and you'll see just one trailing extra space. That's okay. But this is how you print the DQ without using DQ.display.